let's spend some time talking about trigonometric functions. So many of you would have taken a course in high school on trigonometry, probably a year-long course. I can't redo an entire year-long course in the amount of time that we have to spend, so I'm just going to hit some highlights and, and say these are things you definitely need to know. If it feels rusty, go back and review them. And let me also just say that I can't cover everything. I can hit highlights in these videos. So we have 6 basic trigonometric functions: sine theta, cosine theta, tangent theta, cosecant theta, secant theta, and cotangent theta. If we draw a right triangle, let's put that there, where there is theta, and I'm going to label the sides as x, y, and r. Our definitions for sine of theta is defined to be the ratio of y over r, y divided by r. Cosine theta is the ratio of x to r. And tangent theta is going to be the ratio of y over x. Cosecant theta is r over y. Secant theta is r over x. Cotangent theta is x over y. Let me point out just a few relationships here. So cosecant theta is 1 over sine theta. Secant theta is 1 over cosine theta. Cotangent theta is 1 over tangent theta. And also tangent theta is sine theta over cosine theta. So these are the 6 trigonometric functions that you should know. These, and I'm using this, assuming that everything here, these quotients are defined there. Things to know about them: you should know or be able to derive the values of the functions at a list of particular special values of theta. And so I would say at the minimum you should say that theta, you should know these at theta is 0, pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6, pi, 3 pi over 2, and 2 pi. And also maybe some negatives as well. Negative pi over 4, negative pi over 2, negative 3 pi over 4, and negative pi. So there's lots of things going on here. That these are just things that you should know or be able to quickly derive the trig function values. If this is something that's rusty with you, this is rusty for you, this is something for you to practice or talk to me. By the way, important thing here is that we're working in radians, not degrees. So our default preference in this course is going to be working with radians, not degrees. If you're using calculator to do things, make sure your calculator is set to radians, not degrees here. So of course we know, for instance, pi over 6 radians is equal to 30 degrees, for example. Our preferred way in this course is going to be expressing things as radians. I may go back and forth. I may go back and forth between the two, but the default thing is that we're assuming that we're working in radians. And also, the bigger catch is that if you write 30 as your answer without putting degrees, I'm going to assume that you mean radians. If there's no specific degree symbol here, I'm going to assume that you mean radians. You're going to need to put the degree sign if you do want to work with degrees. There's a lot of identities that are useful to know. It is good to have these handy. So maybe the most fundamental one, well, I already talked about the relationships on this slide here, but probably the single most important one is cosine squared theta plus sine squared theta is equal to 1. So this is essentially the Pythagorean theorem. Going back here, to show where this comes from, Pythagorean theorem says that r squared is equal to x squared plus y squared. We know that by Pythagorean theorem. So cosine theta squared is x over r squared plus sine theta squared is y over r squared. And that's going to be x squared over r squared plus y squared over r squared. But x squared over r squared is equal to r squared, and so that's just 1. So this is our most useful trigonometric identity. There's 2 more that are like this, and you can derive the 2 additional ones. First, let's divide both sides by cosine squared theta. So cosine squared theta divided by cosine squared theta is 1. Sine squared theta divided by cosine squared theta, that would be sine theta over cosine theta squared is equal to 1 over cosine theta squared. And of course, sine over cosine is tangent theta. So this is 1 over tangent theta squared, and that's equal to, this is secant theta squared. Now, one more, so I promised there were 2 more after this one. If instead of dividing cosine squared theta plus sine squared theta by cosine is equal to 1 by cosine squared theta, let's divide both sides by sine squared theta. And what do we end up with? Cosine squared theta divided by sine squared theta is cotangent squared theta. Sine squared theta divided by sine squared theta is 1. 1 over sine squared theta is cosecant squared theta. So these 3 identities are all very useful. If you forget these 2, it's very easy for you to rederive it from this one. A few more useful trigonometric identities here. Some addition identities. If you want to do cosine of a plus b or sine of a plus b, cosine a plus b is cosine a cosine b minus sine a sine b. Sine of a plus b is sine a cosine b plus cosine a sine b. We'll definitely be making use of this in Chapter 3. A couple of double angle formulas. Cosine of 2 theta. This is equal to cosine squared theta minus sine squared theta. And sine of 2 theta is equal to 2 sine theta cosine theta. And then a couple half angle formulas that will also be useful later on. Cosine squared theta is equal to 1 plus cosine of 2 theta over 2. Sine squared theta is equal to 1 minus cosine of 2 theta, all of that over 2. So obviously there's a lot more things going on for, with trigonometric functions, but this gives you a taste of what's going on. Let me say one more thing here, which has to do with inequalities. It is useful to know that sine theta is always an absolute value between 0 and 1, and this also holds for cosine theta as well. And then at some point we will make use of the following inequalities, assuming theta is measured in radians, as it should be. Sine theta is between negative absolute value theta and the positive absolute value theta, whereas 1 minus cosine theta is also satisfies these same relations. So these are all useful things to know.